Hello.
Assalamualaikum, ma'am.
Hello, ma'am.
Maisa.
Zarish, ma'am.
Zaresh, good morning, Zaresh. How are you?
Good morning. I'm fine, ma'am. How are you?
I'm fine. Okay, let's wait for a few minutes. Let the students also join. Okay.
Okay, ma'am.
Hello, Chand Khushi.
Hello, ma'am. Good morning.
Good morning. How are you? Okay, let's start. So I'm going to share with you. Let's see. So this is the chapter we have been studying, and so can you tell me something about what we've studied so far, Zarish? Hello, Zarish.
Yes, ma'am. मैम ग्रेविटेशन के बारे में हम लोग स्टडी कर रहे हैं इस टॉपिक पे.
Okay, so can you tell me something a little bit more? Zaresh or Chand Khushi or Maisa? So we did talk about the fact that according to the Newton's law of gravitation, two bodies having a mass m1 and m2 attract one another with a force, right? And g is the gravitational constant, and this gravitational force is proportional to the product of the masses, and it's inversely proportional to the square of the distance between them, right? So we also talked about the fact that capital G is a constant that is known as the gravitational constant. Okay. So we talked about the principle of superposition. We also solved these problems last time in great detail. And we talked about the gravitation of the Earth and the acceleration due to this. And we also talked about the value of this acceleration changing as the altitude is changed, as the height above the Earth's surface is changed. We talked about the gravitational potential energy where the symbol is U, and also we talked about taking infinity as a reference point and taking the value of U as 0 for R is equal to infinity. And as you come downwards, we take the negative value of potential energy. So we also discussed this. And okay. We talked about the escape speed, right? When we throw a projectile, there's a certain speed above which the body will not then return to the earth, rather it will escape. So this is defined as the escape speed, and the formula is given here, and this depends upon the mass and the altitude. So these are some examples of these speeds. And now today we're going to talk about planets and satellites, Kepler's laws. So, can you tell me what is a satellite? Can you give me an example of a satellite?
Ma'am, it revolves around the space and gathers information or just for like telephone signals. It's also used in for other purposes.
Who's speaking?
Zarish.
Zaresh. Okay, yes. Okay, that's you're giving me an example of an artificial satellite. So there can be natural satellites and there can be artificial satellites. So artificial satellites, for example, we have telecommunication satellites, we have weather satellites, and we use them for various purposes, and these are very important, of course. You cannot have your mobile phone, for example, if you don't have these. Technologies. But satellite in general is any planet or moon or machine, if it's artificial, that orbits a planet or a star, right? For example, the moon is also a satellite. The moon orbits around the Earth, which is a planet, right? So we can have both natural and artificial satellites. And again, we have an example here of the path of the planet Mars, for example. And we are also talking about constellations. So, what are constellations? These are different terminologies that we use in relation to astronomy, as I discussed last time. So astronomy is a hobby also. You don't need to be a physics major to be interested in astronomy because it's easy to understand, and even school level children um, can be hobbyists in this field. I gave you many examples of and many events that take place even locally in Lahore related to astronomy. I also told you there's a Lahore Astronomical Society, there's Sparco, there are different science societies that keep organizing these events, right? So normally when you look at the sky and at different parts of the year, depending on the season, the weather, and so on, you see different arrangements of these stars. So this group of stars take different different shapes, and each shape has a name and can be identified, and these are called constellations. So anyway, Kepler was working on these topics, and he came up with three laws. The first law is known as the law of orbits. All planets move in elliptical orbits with the sun at one focus. That's law number one. So in order to understand this law, of course, you should be clear about what is an ellipse. What is an ellipse? What is an ellipse? Yes. What is an ellipse? Chand?
Yes, ma'am.
What is an ellipse?
मैम आइडिया नहीं है.
आइडिया नहीं है अच्छा दिस इज समथिंग you study in geometry in school when you study maths, right? There are different shapes, geometrical shapes. Anyway, Alina, can you answer this? What is an ellipse? Maisa?
Ma'am, it's
Yes, Alina.
ma'am, it's the curve which is joining the straight line, matlab two, the circle.
Okay. So
The
a circle, we are all familiar that a circle is a shape which has a certain radius, and the radius remains the same at all positions, right? So it's a circular shape. But an ellipse is different in the sense that it does not have a fixed radius like the circle. It's more like oval shaped. And in this case, you have one axis that passes through the longer side, and this is known as the major axis, and you have a another axis perpendicular to this, which is known as the minor axis. So you can see the shape of an ellipse. So most of the paths of these satellites are elliptical paths. So this is what Kepler is saying in his law number one, that all planets move in elliptical orbits with the sun at one focus. So when we talk in an ellipse, this is the major axis, the minor axis, this will be called the semi-major axis. And you can see here that there are 2 points, F and F prime. These points are known as the foci of this major axis. And one of them is known as the focus, and if there are two, then the plural is foci. And the sun would be at the position of the sun is normally at one of these points, which are called the foci, and then the earth or the planet will rotate around this in an elliptical path. So the path is not circular, it is elliptical. And then there are various symbols that are representing various distances in this case. For example, the semi-major axis is described by A and multiplied by E is called the eccentricity, and this is R is the distance of this planet from the sun, for example. Okay. And the second law that Kepler gave was the law of areas. According to this law, you know that a line that connects a planet to the sun sweeps out equal areas in the plane of the planet's orbit in equal time intervals. That is, when it is rotating, it is covering a certain area. So in equal time, it will cover an equal area. This area is called A, and the rate at which it is covering this is called dA over dt. So here you have the statement of this law, where dA over dt is equal to L over 2m. L is the angular momentum, m is the mass. Then the third law given by Kepler is the law of periods. In this case, we are talking about the time period, right? We defined the time period in the previous classes, right? Whenever a body moves in a circular path, the time it takes for one complete revolution is defined as the time period. So the square of the period of any planet is proportional to the cube of the semi-major axis of its orbit. So here you have this formula, this time period, T is related to R. Okay. Then of course, when you have satellites, like any body in motion, these satellites do have a certain energy. They have a potential energy, as we have discussed below, and they also have a kinetic energy, and therefore they also obey the rules of energy that we have. So the total energy E is equal to the sum of the kinetic energy and the potential energy. And when we solve these, then we can derive an equation for a satellite in an elliptical orbit of a semi-major axis A. We can get the expression for the total energy E. Okay. And then there is an interesting, we have been talking about gravitation and Newton's contribution to gravitation, and which is important. And after that, later on, work was done by Einstein on gravitation, which really added a lot to the existing knowledge we had on gravitation. So Einstein gave us the general theory of relativity, and he also based it on the principle of equivalence. So according to Einstein, the fundamental postulate of his theory about gravitation, which is the gravitating of bodies towards each other, this is called the principle of equivalence, according to which the gravitation and acceleration are equivalent. So there's an example here. For example, if you have a boy in a box, let's say, then he will experience and let's say the box is moving with a certain acceleration. Now this boy will not be able to identify any difference whether this box is placed on the earth or it's placed in space, as long as it's moving with the same acceleration, let's suppose, which is 9.8, as we discussed in general. When a body is on the surface of the earth, it's moving with an acceleration of 9.8. So if the acceleration remains the same, the boy inside the box will not be able to perform any kind of experiment to prove whether he's on the earth or he's in space, because he will have the same kinds of experiences. Also, if he tries to measure his weight with the help of the scale, the weight will be the same, because the weight is equal to mg. So if the value of g is the same, the weight will also be the same. If he tries to throw an object downwards inside this box, again that object will also fall with the same acceleration, and again he will not be able to identify that whether he's on the earth or he's in space. So this is the principle of equivalence, which was given by Einstein. Another very important concept given by Einstein is about the curvature of space. Okay, so according to this, Einstein spoke about space and time together. Space is, let's say, three-dimensional space, x, y, z, and then he added another coordinate of time, and therefore four-dimension. He said that the universe is four-dimensional, and he described this as a curvature. It's a curved surface, let's say, and curvature you can imagine like a trampoline. You know what is a trampoline? Something like a stretched membrane. Trampoline, children normally jump on trampolines. It's a stretchable surface on which, if you put a body on such a surface, you can imagine a stretchable membrane, like let's say a balloon membrane or a rubber membrane or a trampoline membrane. And if you throw a ball inside this membrane, you throw two balls, you will see that the two balls will fall towards each other. So this is the concept of curvature of space, and that's how Einstein described gravitation. So in these diagrams, you can see this is the curvature, the curved space, and you can see that if the earth inside this, if a massive object is placed inside this, it will stretch it downwards. And here you can see there are different examples. For example, the earth is a sphere, but let's say if two boats start traveling in parallel paths, from let's say the equator towards the south, they will think that they're traveling in parallel paths, but actually their paths will go and converge to a point. Okay, so this is because of the three-dimensional spherical nature of the earth. Okay, So these are different. Even another example can be with apples. If you throw two apples downwards on parallel paths, you will think that you're throwing them on parallel paths, but actually their paths will again join each other because they will both be attracted towards the center of the earth. And this is again gravitation, and you will see that their paths are converging. And the same happens with light. When light passes near the earth, the path of the light bends slightly because of the curvature of space, and this effect is called gravitational lensing. There's another term that's related to gravitation, but it's quite advanced, and it's also named in the form of a fundamental particle, which is called a graviton. So these are some very interesting concepts about the concept of gravitation. I also told you last time that gravitation is a topic which is very popular among hobbyists, people who are not even physics majors, and it's easy to understand. And you have a lot of sci-fi movies and documentaries and videos available about these topics, and you can also adopt it as a hobby, looking at the stars, studying the planets. It's very fascinating. There are a lot of apps and softwares you can download, and you can see them in real time, and there are many beautiful images that you can see. Okay, right? So let's solve an example, a problem related to this concepts that we just studied. So let's look at this one. In this case, an astronaut releases a ball, a bowling ball. A bowling ball is different than a football. You do understand that, right? A bowling ball is not hollow, right? It has a certain mass. So this mass is, let's say, 7.2 kg, and it's moving in a circular orbit about the Earth at an altitude h, which is equal to 350 kilometers. So what is the mechanical energy E of the ball? So the formula for the mechanical energy, just as we studied before, is E is equal to minus G, which is the gravitational constant, the mass of the earth, the mass of the ball multiplied together divided by 2 multiplied by r. R is the distance which is between the two bodies. Now in this case, r will be equal to the radius of the earth plus the height above the earth, because we are starting from the center of the earth. So the radius of the earth, you can find this value in any table. It's given here. And then you add the altitude h, which is 350, and the total value of r comes out to be this. You now have the mass, which is, where is the mass? The mass is 7.2 kg. You put it here. Then you have the mass of the earth. The mass of the earth is a constant. You can get this value from the tables. Again, I uploaded some tables in Moodle as well, and you have some tables in the beginning of this book. You can also see those. So you can put the value of the mass of the earth. This is a measured constant value. You can put the value of the gravitational constant. Again, this is a constant value that's given in the chapter. You multiply it by the mass of the ball that's rotating, and you divide it by the distance r that you've just calculated, and you will get the total mechanical energy, which is a huge amount. It's 10 raised to 8, so it's in megajoules. Mega means 10 raised to 6. Okay, so the second part is, what is the mechanical energy E naught of the ball on the launch pad at a certain point, let's say Cape Canaveral. From there to the orbit, what is the change delta E in the ball's mechanical energy? So in this case, we use the formula where the energy, total mechanical energy, is the sum of the kinetic energy and the potential energy, right? So the kinetic energy and the potential energy will both contribute towards this system. We have the formulas for each of them. We know that the potential energy is given by the formula we just discussed in the previous section. So this was again based on the masses of the two bodies and the distance r. So we will substitute these values here. So you get these values. Also remember that this is kilometers, and kilometers has to be converted into meters. And you will get the value for the mechanical energy in this case. The kinetic energy is due to the ball's motion, and therefore the kinetic energy will be much less as compared to the potential energy, because the potential energy is in megajoules. Kinetic energy will only depend upon the ball's velocity, which cannot be so huge, and therefore it can be neglected. And so we will say that the total energy is approximately equal to the potential energy in this case. So the increase in mechanical energy of the ball will be a difference in these two energies that we have calculated. The first one was minus 214 megajoules. The second one is minus 451 megajoules. And when you find the difference, this is the difference. So the question was about the change, the increase, and this is the increase. Okay. So now I can share a video with you that explains these concepts that we were just studying. So this is an illustration of how we can explain them. So let me share this with you. Can you see the video? Can you see the video?
And their paths never.
Can you see the video?
Yes,
Yes,
ma'am.
ma'am.
Okay, so you can see these are two lines which are parallel, right? So we start from here, okay?
About shapes and geometry is the concept of parallel lines. Two lines that both travel in the same direction and their paths never cross. Well, let me tell you, reality is a lot more complex. All our lives we've been told we live in a three-dimensional space, or the third dimension, those dimensions being height, width, and depth. Now, this is superficially correct, and thinking any different won't change your life, but the reality is we exist within a four-dimensional realm called space-time. We have freedom of movement within three.
So this is the curvature space we were just talking about. So space being x, y, z, and then adding time, we get the four-dimensional curved curvature.
Three of these dimensions, space, but the fourth, time, is restricted. This means I can move in any direction within space at any speed or any acceleration. My only constraint is the energy needed to change my momentum. But in the fourth dimension, time, I can only go one direction at one speed. For that reason, we are considered three-dimensional beings. We don't possess the ability to comprehend the fourth dimension. But that doesn't mean it doesn't exist, and believe it or not, it's why things are attracted to each other by what we call gravity. In order to comprehend space-time and how the fourth dimension creates gravity, we need to be able to comprehend how higher dimensions affect lower dimensions. So to begin, let's pretend we have a pair of one-dimensional friends, friend A and B.
So one dimension is a line, right? An example of one dimension is a line, right? You know, from geometry, we study 0 dimension, 1 dimension, 2 dimension, 3 dimensions. One dimension will, 0 dimension will be a point. One dimension will be a line. 2 dimensions will be a circle. 3 dimensions will be a sphere, okay? So this is what we are explaining here.
And these friends, they get in a fight and decide, I'm done with you. And they start walking away from one another in opposite directions. Then, after a while, all of a sudden, friend B pops up out of nowhere and both of them lose their minds. How is this possible? There's no conceivable notion other than teleportation of how these two friends could possibly meet up again. Their one-dimensional minds are just unable to comprehend what is happening, because their world is actually a circle within two dimensions. However, without information from the second dimension, it's impossible to know the true direction of their path, or any path for that matter.
So, for example, if for example, two people are moving in a line, they will think that they're moving in a line, but actually they're moving in a circle. And if they're moving in a circle, their paths will meet each other. They will converge. That's what it is about, right?
Therefore, the one-dimensional friends are bounded by the second dimension. The same thing happens for those living in two dimensions. These friends walk away from each other, turn 90 degrees to their north, keep walking in parallel lines, and yet...
So this is the example of, in your book as well, in the diagram where they showed the equator and two boats that started racing each other in parallel directions, in parallel lines. They thought they were going parallel, but actually because the earth is spherical, they will meet at a certain point towards the south.
somehow,
and in that case, the example was towards the south. In this case, the example is towards the north.
they run into each other. That is because they actually exist upon a sphere. Again, without information on the third dimension, it's impossible for them to conceive the true nature of the path they are taking. That brings us to our world, the third dimension. And yes, we too are bounded by a higher, the fourth dimension. Just like our friends in the previous two examples, there's no way for us to conceive exactly how we can travel in straight parallel lines and meet up again, but we can understand that our plane of existence is curved in the next higher dimension. What does that mean? We have no idea, just like our friends from before, but that doesn't mean we can't understand the consequences of it. This curvature in the fourth dimension is what we experience as gravity, and just like how everything in the lower dimensions that travel in straight parallel lines eventually meet up, the same thing happens here in the third dimension. However, here things differ a little from our friends before. Unlike our lower dimensional friends, we don't have the freedom to choose how fast to move through our four-dimensional space-time. Whether you are running, sitting, or falling, you are moving through space-time at the notorious speed c, roughly 300,000 kilometers a second. This is of course the same c from the famous E equals mc squared postulated by Einstein, and it is equally distributed between space and time. So, if you decide to move faster through space, you must move slower through time. And if you were to somehow slow down in space, you'd move faster through time. Now, you may be thinking, well, I'm just sitting here.
Okay, I'm going to forward it. I'm going to give you the link. You can watch
this. You'll have the same matter, normal and dark
so
light.
This is the example of the trampoline. We talked about the curvature, the stretched membrane. And if this is the earth and this is the moon, you will see the bodies will cause the curvature.
On space-time.
They will be attracted towards each other and they will move along these lines like it's shown in the diagram.
Now, although they exist within space-time, the elementary particles that make up all matter are not on them. That means no matter where you put them on a sphere, is that they all, because straight lines on curves have unique behaviors. A straight line along a curve is called a geodesic, which is very important because
for example, in your book, you just saw the diagram where the curvature was shown, and if you place a massive body like the Earth,
that should be they exist within space-time.
It will bend the curvature downwards. So you can see this, and I will upload the link for this, okay, for you, because we would now like to also ये सोहेब ताहिर इस वक्त enter हो रहा है. Soheb Tahir, you're so late. Why are you guys so late today? Many people have been very late today. तो फिर उनकी attendance नहीं होनी चाहिए ना?
मैम वो पीटी के इश्यूज अनएक्सपेक्टेडली आ गए थे. पहले ज्वाइन करके डिस्कनेक्ट हो गया था मैं पहले सेकंड में.
बस दैट्स
इसलिए मैं 5 मिनट लेट हो गया था.
मेरे साथ भी ऐसी है, बाबा डिस्कनेक्ट हो रहा है.
सबका आज डिस्कनेक्ट हो रहा था मेरे अलावा, है ना?
ये मैम आपका इंटरनेट अच्छा होगा.
नहीं बेटा, मैं भी यहीं पे यही वाला इंटरनेट यूज कर रही हूँ जो आप लोग करते हैं, ठीक है? I don't have any special internet, so please be in the class on time. वरना क्या फायदा? अटेंडेंस तो नहीं.
मैं आया स्टार्ट में 5 मिनट के लिए डिस्कनेक्ट, इंटरनेट नहीं चल रहा था.
So okay, आप पहले से अपना डाटा फिर कर दिया करो अगर नहीं चल रहा था तो, ठीक है? Because you know that your exams and quizzes are also taking place on the internet, and you should have an arrangement, a backup for this, ठीक है?
Okay, ma'am.
And let's see. Okay, so so your homework now, please start preparing for your homework. Your homework this time will be from this chapter, and it will be from the next chapter that we will start on Monday. So start preparing these, and also, you know, after that you will have your final exam. So you should also start preparing towards the final exam. The details of the topics are given in your combined course outline, right? Which has been uploaded in Moodle. I've also shown you, but be careful that this the course outline is mentioning the topics only. It's not mentioning the chapters, whereas in your book you have the chapters. So I have been discussing from time to time how the chapters correspond to the topics. So prepare them accordingly, okay? ठीक है? So your homework is to study and practice and prepare for the next upcoming graded homework assignment that I will be giving you. Okay? ठीक है?
Yes, ma'am.
Okay, ma'am.
Mm. Okay, so let me just share this with you. I'm going to share this outline with you. Okay?
Ma'am, attendance.
Attendance मैंने लगा ली है. अब बताओ जो late है उनको क्या करना है?
मैम मैं
देखो
तो 5 मिनट लेट आया था सर.
हाँ, कोई 5 आया, कोई 10 आया, कोई 15 आया, कोई अभी थोड़ी देर पहले आया. That's the point. अच्छा देखो, we are
मैम मैं
studying.
स्टार्ट में भी आया था,
अच्छा,
मैं
let's
डिस्कनेक्ट हो
not
गया
waste.
था.
No, there's no point in wasting time. Let's come back to what we were discussing. So we are talking about the course syllabus. We are on topic number 9, which corresponds to, no, sorry, topic number 10, which corresponds to gravitation. This is chapter 13. After chapter 13, we've completed chapter 13 today. And now next time on Monday, I will start this topic number 9, which is oscillations, chapter number 15 in the book. So these two chapters will be given in the next homework. And the date for your next homework is 28th January. So please prepare yourself.
28.
This assessment plan has been uploaded in Moodle as well. So it's 28th, and the next upcoming homework is on the 28th of January. Okay. So before that, you prepared. You have a lot of time since we started doing chapter number 13 and chapter number 15. These are the two chapters that will come. And also, you know that your final exam will be topic number 6 to 10. Topic number 6 to 10 means this will be chapter number 7 to 11, and then 13 and 15. So these are the chapters that you will have to prepare for this. And also remember that we will be please regularly do your homework related to your lab work, because your lab work will also be graded. Okay? Is that clear?
Yes, ma'am.
Okay. So
लैब वर्क एक बार रिपीट कर देगी.
lab work is being uploaded regularly every Wednesday. Okay, so please go through the material that's given in the lab work and practice it. You have your manuals, you have your worksheets, you have the I'm uploading links for the virtual labs where you can practice these materials, and I'm also uploading presentations and demonstrations. So वो लोग आप लोग कर रहे हो कि नहीं कर रहे हो?
Yes ma'am.
Regularly karo. This is not something you can do in one day or one night or one weekend. Okay? So you have your homework for the theory, and you have your homework for the lab. Okay, for the theory, I want you to study and practice the chapter that we are doing. We have finished chapter number 13. 13 tha na ye? Yes, 13. Okay, so practice this chapter, and your homework deadline is for graded homework 4. Graded, the deadline is 28th Jan. Okay, and this will be chapter 13 and chapter 15. And we have completed chapter 13. You can prepare this, and on Monday we will start with chapter 15. Okay. This is one homework for you, okay? And the second homework is for the lab. You have to study and practice all lab material. Every Wednesday, spend at least 2 to 3 hours on the lab material. And so this lab material is in the form of your worksheets. You have your worksheets, go through them. And then we are also uploading, I am uploading the presentation related to that to describe the practicals and all that. Then the demonstrations are in the form of videos within those presentations, okay? And then I am also giving you the virtual lab links where you can practice them, okay? For practice. So prepare this, because lab work is also, according to the course outline, the lab work is going to be it's going to be a considerable percentage of your final assessment. So you have to, it's graded, okay? So therefore, please be careful and do this regularly. Don't think that you will be able to do it at the last moment, because we're now near the end of the semester. You can see that we are in at the end of Jan, and in Feb we will start planning the exams, and therefore you should be studying regularly. So Monday, Wednesday, and Friday you do your, it's not just attending the class is not enough, you also study and practice, spend time for self study, and also prepare yourself for the final exam. The first step is of homework, and then you start preparing for the final exam. For the lab, again, this is a graded activity. It's 15% of the total course grading, and therefore you should use all the material that you have and practice it. So whether it's online or offline, you should be practicing. You should not, we have not missed any lab. Okay, every Wednesday you've been provided with lab material. So please go and study and practice this lab material.